In a daring announcement, scientists claimed to have discovered a new planet unlike anything known before. NASA, renowned for its groundbreaking findings, has revealed that this planet is fascinating not only because of its size and location, but also due to the presence of lights that appear to be artificial. Could we be on the verge of uncovering secrets that might transform our understanding of the universe? Could this discovery indicate the existence of life on other planets? By exploring NASA's remarkable findings, we may soon uncover the truth behind these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with the mission of exploring some of the most intriguing objects in our solar system. Equipped with 3 ion engines, Dawn was capable of embarking on an ambitious journey that began with a 14-month study of Vesta, the second largest asteroid in the asteroid belt. Dawn sent back detailed images and data that revealed Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn began the second, and perhaps most exciting, part of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a feat that traditional chemical propulsion would not have allowed. These engines provided a gentle, continuous thrust that enabled the spacecraft to travel vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is both the largest and most massive body in the asteroid belt and one of the most fascinating due to its unique characteristics. Scientists eagerly awaited the first detailed images of this mysterious world, which revealed bright spots scattered across its surface, especially in a large crater known as Akator. These bright spots immediately sparked interest and speculation within the scientific community. Prior to Dawn, the best image of Ceres was a blurry, low-resolution one taken by the Hubble Space Telescope. Very little was known about the dwarf planet, and the prospect of finally obtaining a close-up view promised significant discoveries. The Dawn mission aimed to improve our understanding of the solar system's formation and the role of water in the development of planetary bodies. The bright spots on Ceres, also seen on other asteroids, were believed to be composed of highly reflective material, possibly salts left behind by sublimated water. This discovery suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt not molten rock but liquid water or brine. But what exactly are these mysterious lights, and what do they reveal about the nature of Ceres? Could they be evidence of ongoing geological activity, or something even more extraordinary? Ceres stands out from other bodies in the asteroid belt due to its size, mass, composition, and potential to contain water and ice. Unlike typical rocky asteroids, Ceres has a more comet-like composition, suggesting it may reveal more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a major milestone as it prepared to provide the first close-up views of the largest object in the asteroid belt. As Dawn drew nearer, images of Ceres became increasingly detailed, unveiling a world previously cloaked in mystery. The early images showed a cratered surface that indicated a long history of impact. However, what caught the attention of scientists and space enthusiasts alike were the mysterious bright spots that stood out starkly against the dark, rocky terrain. As image resolution improved, the scientific community began to form theories about the nature of these bright spots. Were they patches of ice reflecting sunlight, or could they be something more exotic? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity, but rather a cluster of several distinct spots. The most widely accepted hypothesis was that these were salt deposits left by sublimation of water. This implied that Ceres had, or still has, some form of geological activity capable of bringing water or brine to the surface, where it quickly evaporates, leaving behind bright, reflective residues. These findings challenged previous assumptions about Ceres, painting a picture of a more dynamic and complex world than had been imagined. The potential presence of groundwater or brine pockets could have profound implications for our understanding of life's potential in the solar system. Ceres is an intriguing dwarf planet, often described as an icy world with a rocky but porous surface. Unlike most asteroids, which are composed primarily of rocks and metals, Ceres is notable for its unique composition. Its surface consists of water ice and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition suggests that Ceres contains a significant amount of water. Its surface layer is rocky yet porous, with ice and other volatiles trapped within, making it more like a comet than a typical asteroid. The dwarf planet is believed to have a distinct internal structure composed of a muddy mantle and a core. Rich in water ice, which may account for approximately 50% of Ceres's total volume. The mantle is likely a mixture of rock and brine, surrounding a denser core possibly made up of silicates. The presence of a substantial amount of water ice raises the possibility that Ceres may have hosted liquid water in the past, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from neighboring asteroids and raises intriguing questions about its geological activity and the role water has played in its evolution. Furthermore, the discovery of ammonia-rich clays on Ceres suggests that it may have formed in a colder region of the solar system before migrating inward. Ammonia has the potential to lower water's freezing point, supporting the existence of surface brines. These insights into Ceres's composition and history not only deepen our understanding of this fascinating dwarf planet, but also offer valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, especially when compared to the more familiar volcanic activity observed on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, eject substances like water, ammonia, or methane. These materials can exist as liquids or gases in the extreme cold environments where cryovolcanoes are found. On Ceres, cryovolcanoes function by allowing water laced with dissolved salts to reach the surface. When the salt water contacts the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid state to a gas, leaving behind glowing reflective salt deposits. These salt residues form the mysterious bright spots observed on Ceres's surface. The most famous of these spots is located in a crater known as Okator. This area has garnered considerable attention because of its high reflectivity and the periodic hazes observed by the Dawn spacecraft. These hazes are believed to be caused by water sublimation, suggesting that cryovolcanic activity may still be occurring, or may have occurred relatively recently, on Ceres. In addition to a crater, Ceres hosts several other bright spots, each with its own unique characteristics. These features are not confined to a single region but are scattered across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon. The presence of these bright spots highlights Ceres's dynamic and active nature, challenging previous beliefs that it was a geologically inactive world. As the Dawn spacecraft provided more detailed images of Ceres, a wide array of surface features began to emerge. The dwarf planet's surface is dotted with craters, each telling the story of its rich and complex history. Let me know what you think in the comments box, and if you enjoyed this exploration, remember to like and subscribe.